All right, now we're ready to talk about section 4.7. Now 4.7 is going to work with graphing again. Most of this is stuff we already did when we were graphing quadratics, the parabolas. So a lot of it's the same stuff. So you got kind of 4 or 5 things to look for. First, if there's a number in here with the x, like x minus h, that's a horizontal shift or horizontal translation. It goes left or right. And anything in with the x, it's kind of the opposite of the way it looks. Like here, notice inside there's an x minus 5. Well, that's shifted 5 to the right. If inside there was an x plus 2, that's shift left 2. Because it's x minus h, so that's opposite. Then, if there's a number on the outside, so it's not in with the x, number outside, that's k usually we use for that, that shifts the graph up or down. So like this one, on the outside, so it's not in the parentheses, there's a plus 1, so you go up 1. Here there's a minus 4, so you go down 4. So like in our general equation, it looks like this. So if there's a number inside here, you move it left and right, the opposite of h. If there's a number out here, you move it up or down, whatever k is. Now the next thing is reflections, and this is if there's a negative in front of the x or in front of the whole thing. Now this one we did not do before. Notice here the negative x, the negative is inside with the x. Anything that's inside is horizontal. So if there's a negative in with the x, that shifts the graph horizontally. So it flips it across the y-axis. So if you had a point like at 1, 2, now it's going to shift to negative 1, 2. So you take the x coordinate times the negative 1. Now this one we did before, if there's a negative on the outside, so it's not inside with the x, that shifts it across the x-axis, so that shifts it vertically. So if there's a negative out front, it flips it vertically, or you could say it's inverted. Now the transformations, these are when it's stretched or shrunk. Again, this one we did not talk about for horizontal. Notice that there's a number in. Now in your sheet they used an A. When I wrote it over here, I used a B just so we could tell the difference between A and B. Notice here, the x is multiplied by b inside the parentheses. When it's inside, it's horizontal, and again, we kind of think opposite. So here, if that number is a number like 2, we're going to shrink this by a factor of 1/2, the reciprocal, 1 over 2. So what happens is you would take every x coordinate of the point and multiply it by 1 over 2, by a half. If that number is a fraction, like here, 1/2, let's say that was 1/3, that means it's going to be stretched horizontally by 3, because the reciprocal of 1/3 is 3. So that means you would multiply all the x coordinates by 3. This one gets a little tricky sometimes. Thank goodness we don't see very many of those. Then the last one, this is the one we already have talked about. If there's a number multiplied out front, that's a vertical stretch or shrunk. So like here, if there's an 8 out front, that means it's stretched vertically by 8. So you would take every y coordinate and multiply it by 8. If there's a fraction like out front, like here, 1/4, then it's shrunk vertically by a 4th. So it looks shorter than it did before. You would take every y coordinate and multiply it by 1/4. So that's the basics. And I wrote this on here like this, but these are all the things here. A is vertical stretched or shrunk. If A is negative, it's flipped vertically. It's inverted. Inside here, if there's a number subtracted, if there's a number in here, that's shifted left or right. If there's a number multiplied in front of the x, but inside the parentheses, that means it's stretched or shrunk horizontally by 1 over whatever that number is. And if there's a number added or subtracted on the outside, that shifts the whole graph up or down. So what we're going to be doing is just shifting these depending on what they tell us. Like notice this one says, we have the basic graph is f of x equals x cubed. Well, let's graph that on here. F of x equals x cubed. Let's say if I plug in some numbers, 0, 0. If I plug in 1, I get 1. If I plug in 2, I get 8. If I plug in -1, I get -1, -2, -8. So that graph normally looks like this. Okay. Well, now notice here we have this. x plus 5 cubed plus 2. You always start inside the parentheses. So there's a plus 5 in here. That's the h we talked about before. So that plus 5, and we always think opposite. So this graph is moving left 5. And then it's got a plus 2 outside. That's a vertical shift, and up 2. We're going to do those two things to our graph. We're going to shift it left 5 and up 2. So like this point here in the middle, left 5. So 1, 2, 3, 4, 5, and up 2 moves it to right there. Or this one here, left 5, 1, 2, 3, 4, 5, up 2. Or this one, left 5, 1, 2, 3, 4, 5, up 2. Here, left 5, 1, 2, 3, 4, 5, up 2. Or here, 1, 2, 3, 4, 5, up 2. So that graph would look like this. Okay. Number 2 here, notice now the original graph is x to the 4th. Well, that's going to look like sort of like a parabola. Let's plug into numbers like 0, x to the 4th, 0 to the 4th is 0. 1 is still 1. Now 2 to the 4th would be 16, so that's way up above somewhere. Negative 1, 1, negative 2, again 16, so way up here somewhere. So the original graph looks something like this. And it's kind of wider at the bottom than a normal parabola. When it's x to the 4th, it tends to be a little wider on the bottom. Colored outside the lines there. All right, now what we have here is x minus 3. Again, there's a minus 3 in with the x. That means right 3. And on the outside, there's a minus 1. That means down 1. So again, we take those points, like here at the vertex. If we go right 3, 1, 2, 3, and down 1. Or this point here, right 1, 2, 3, and down 1. Or this one over here, right 3, 1, 2, 3, and down 1. You just shifted all these points, those two things. So this graph is going to look like this. Okay, those are just straight shifts. All right, let's look at the next one. Now we have some transformation going on. Again, here we start with f of x equals x to the 4th. Well, we just graphed that. We know it's 0, 0, 1, 1, 2, 16. Negative 1, 1, negative 2, 16. So that graph looks something like this. Now here we have a 3 in front. Remember we said if there's a number in front, like that's in the A spot, that means this graph is stretched or shrunk vertically by that number. Well, here that's a whole number, so this one's going to be stretched vertically by 3. So this one is stretched, because that's a whole number, stretched vertically by 3. So that means we multiply every y-coordinate times 3. So this one was 0, 0. Well, our y-coordinate is 0. 0 times 3 is still 0, so we're going to stay right there. Now this one, our y-coordinate is 1. Well, now we're going to multiply it by 3. 1 by 3 times 3 is 3, so the point 1, 3 is on there. Same way here, our y-coordinate is 1. 1 times 3 is 3, so negative 1, 3. So this graph is just going to look kind of like this. Okay. Now this one's got more than one thing going on. Again, it's an x cubed graph. We did that before. It goes to 0, 0, 1, 1, 2, 8, negative 1, and negative 1, and negative 2, negative 8. So this graph looks like this. Now, if we look at this, we need to start inside the parentheses and work our way out. X plus 2, that means left 2. Then the next thing is this 1/2 out front. Well, that's our vertical transformation. So that means this one is is shrunk vertically by 1/2. Or if that number is less than 1, then it's shrunk. Then we have a minus 1 out here, that's down 1. It doesn't always make a difference.